want to go back to number 2, that number that was actually difficult for you. They say that you have a velocity vector of magnitude 1.2 meter per second horizontal. I'm gonna draw 1.2 centimeters, so not 2.1, so this is 1.2 centimeters. And then on the tip of this one, I need to draw a vector that is 2 centimeter long, because vector 1 is 1.2 meter per second and vector 2 is 2.0 meter per second. So it's gonna be 2 meter per second in this direction, or this direction, or this direction, or any direction. Okay, you can simply use a compass to draw an arc of a circle of radius 2 centimeters. So now this is vector 1. Vector 2 is pointing in any direction. The resultant should be vertical. So this is also, so you draw all this arc. While joining, so these are pointing in this direction. So the question is, if you have vector 1 and vector 2 is one of these, of length 2 centimeters or 2 meters per second, which vector 2 will actually give you a resultant that is vertical? So if you draw a vertical line, this vector will actually give you a resultant that is vertical. Now let me fetch another pen to show you what I ended up doing. This is 1.2 centimeters. This is 2 centimeters, so, or meter per second. And the resultant of these two will end up being vertical. How would you like this? So initially I gave you the example to do the parallelogram method. It's really difficult. The tip to tail method is always much easier. I'm gonna start with question number 3. What you have in this question is the following. You were supposed to draw a vector. It's a displacement vector of length 5.0 kilometers. As a quick reminder, this is east, this is west, this is north, and this is south. All right, so this displacement vector is pointing to the east. I don't have a ruler that will take me 5.0 kilometers, so I'm gonna use a scale. Every 1.0 kilometers will be represented by 1 centimeter. So you can draw this one having a length of 1 centimeter using your ruler. 5 centimeters, I mean, because we're talking about 5 kilometers. This one has to be 3 centimeters long. And this one is pointing east. It's gonna be 4 centimeters long. And now you will need to find the resultant. So this is your resultant vector. You can simply measure the length of the resultant vector and measure the angle in this angle. So how would you answer? R will be equal, the value, the magnitude of R will be equal to question mark, and the angle is gonna be equal to question mark. My time to do the calculation, and I found out that the resultant measured with a ruler is actually something very close to 9.5 centimeters or 9.49 centimeters, which would be 9.49 kilometers. Also, I wanted to give a direction for the resultant. It's up to you. You can simply say it's shown by the figure. In my case, I measured this angle and it turned out to be 18.4 degrees. You can say above the horizontal, above the east direction. You can say it's north of east, anything you want. Now, if I need to do the calculation, I can also elongate this rectangle. And a quick reminder, this is 3 and this is 4. Find those answers using simple calculations. I can fix this, like elongate this rectangle. So I would have a right angle triangle, the size of which will be 3 in this case and 9 on this side. And you can do the Pythagorean theorem by having a side 3 and a side 9.0 kilometers to find the resultant. You do the calculations and you get this. Concerning the angle, you can simply do tangent theta. to be equal to opposite over adjacent, which is 9 kilometers, and you find the angle and you will find 18.4 degrees. Actually have the velocity vector has a direction that is changing. So the direction is actually changing, but the magnitude is constant. So the magnitude is actually constant and it's equal to 6.0 meters per second. Okay, now the question is they want the change in the velocity, or what I would call delta V, between A and B. To be able to do so, I should do V final minus V initial. How would I draw V final? VB is actually pointing downwards, so yes, this is VB and it should be 6 centimeter long. VA, so basically this is the vector VB, 6 centimeter long. I'm gonna draw negative VA, and negative VA should be pointing opposite to VA. So this is negative VA, the length of which should be also 6 centimeters. So this should be a little bit longer. And now this is how you would be finding the resultant. To be able to find the resultant, you simply say, you do the measurements, or you simply do 6 squared plus 6 squared and square root of the answer. You will end up with 8.49 centimeters. So the resultant, or this one, will have a magnitude of, so I'm gonna split it into magnitude to be equal to 8.49 centimeters or meter per second. And concerning the direction, I'm gonna simply say as shown in the figure, okay, as shown below. This is concerning part A. In part B, they want the change in the velocity between B and C. So I'm gonna do V final, which is VC, minus V initial, which is VB. Drawing VC is pointing in this direction. So this is VC, the magnitude of which is 6 centimeters or 6 meters per second. This is negative VB. So negative VB has a magnitude of 6 centimeters, and this is how the resultant would be. The resultant will have a magnitude of actually the same magnitude, 8.49 meter per second, but the direction will be showed in the figure below. Okay, so you see that maybe I can call this resultant 1 and this resultant 2. You see that the resultant 1 and the resultant 2 will change the direction but not the magnitude. So the change in the velocity will have always a constant magnitude but a different direction. Later on in topic 2, maybe 2.2, you will understand what the change represents.